What is the square root of 9604? 9604 is a perfect square. What is its root? So if you want to solve this problem, please pause the video because I'm going to solve this problem right now. So welcome to another video on prime logic. Today I want to share a method for you for finding the root of perfect squares, right? Perfect square numbers. Obviously, in the day of the exam or math Olympiad or somewhere, you don't have the calculators, and if you just randomly try some numbers, chances are you would waste a lot of time. So let's just go with this approach, and I think you're going to save a lot of time. I think you can find it by second, so in less than 10 or 15 seconds. So step one, we just care for the first step. We just care for the units digit, the last digit of this 4-digit number. So this method just works for 4-digit numbers. So 4, let's just write it here. That's step 1. And we need to find the 1-digit numbers from 1 to 9 and find which one has a square that ends with 4. So let's say from 1 to 9. Which one has a square that ends in 4? So let's go one by one. So 1 squared is 1. It doesn't end in 4. That's not our option. 2 squared is 4. It ends in 4. So 2 is one of our options. 3 squared is 9. So it doesn't end in 4. So once again, we need a square of 1-digit numbers that ends in 4, or the last digit of this bigger number. So 2 squared is 4, 3 squared is 9, it's not our option. 4 squared is 16, it doesn't end in 4. 5 squared is 25, doesn't end in 4. 6 squared is 36, doesn't end in 4. 7 squared is 49, it doesn't end in 4. 8 squared is 64. 64 ends in 4. So 8 is one of our options. So 8 squared is 64. 64 ends in 4. 9 squared is 81. It doesn't end in 4. So that's finished. Just from 1 to 9, single-digit numbers. So for this approach, after the first step, we can say that our number, the root, the answer ends in either 2 or 8. We don't know which one. We're going to find out in our next step. So first step is over. Let's go for the second step. So for the second step, let's just chop off the last 2 digits and just focus on the first 2 digits. So 96, let's just write it down here. 96, and now we need to find a number whose square is closest to 96. So once again, we need to find a number whose square is closest to 96, and it must be equal or less than 96. So let's go for 8, for example. 8 squared is 64. 9 squared is 81. 10 squared is 100. Okay, so 100 is bigger than 96, so this can't be our option. So we need a number whose score is closest to 96 and it must be equal or less than. So now we found 9. So we can say that 9 is the tens digit, right? So we have the tens and the units digit. So 9 is the tens digit now. So our root, our answer is either 9, 2 or 9, 8. So one of them, 92 or 98, is the root of 9604. But which one? Let's try one more time to find one last step. It's almost done. So after finding the tens digit, which is 9, so let's just multiply 9 by 1 digit more, or 9 plus 1. So 9 times 10 equals 90. Okay. So now we need to compare 90 with 96, or the first two digits of our original number. So which one is bigger, 90 or 96? So obviously 96 is bigger. Now we go with the bigger option. So if it was smaller, we would go with the smaller number. So since 96 is bigger than 90, we choose the bigger option. So our final answer is 98. So 98 is the square root of 9604. In other words, if we raise it to the power of 2, it'll be 96. It gives us 9604. So first example was a little, we need a detailed explanation. Let's go with another example. Let's go with root 6724. So again, we have the last digit, or the units digit, is 4. So one more time, let's just write down 4 here. It's similar to the previous one. So we just go with a number because we have already talked about it. We have already found it. So among the single digit numbers, so which one has a square that ends with 4? So we've already done it in the previous step. So that's either 2 or 8. So we can say that our root of 6724 ends either in 2 or 8. But let's chop off, so that's maybe the most important step. Let's chop off the last 2 digits and focus on just 67. Let's find a number whose square is closest to 67, and it must be equal or less than, not bigger than 67. So for example, 6 squared is 36. Okay, let's go with 7 squared is 49, and 8 squared is 64. 9 squared is 81. So 81 is bigger than 67. So we're going to stick to 8 squared, which is 64. So 8 is our tens digit. So the final answer is either 8, 2, so this is the units digit that we found in the first step, or 8, 8. In other words, 88. So 82 or 88. But which one is the correct answer? So one last step is just to multiply 8, or the tens digit, by 8 plus 1, or 9. So 8 times 9 is 72. Now compare 72 with the first 2 digits of our original number. So 72 compared with 67. Which one is bigger? Or let's compare from 67's point of view. So 67 is smaller than 72. In other words, we should go with the smaller number. That's going to be 82. So 82 squared equals 6724. Because 67 is smaller than 8 times 9. So let's go with another example here. So for example, let's find square root of 4489, and this is a perfect square. So this method just works with perfect squares. There is a generalized method, however, but this is out of the scope of today's video. If you want to learn this general holistic generalized method, just let me know and I will record a detailed video about it. So again, but this one is an interesting one because the units digit is 9. So the previous ones were 4, so now it's 9. So from 1 to 9, which are the single digits. So which one has a square that ends in 9? So 1 squared, no, it's 1. It doesn't end in 9. 2 squared is 4, doesn't end in 9. 3 squared is 9. It ends in 9. So 3 is one of our options. 4 squared, 16, no. 5 squared, 25, no, it doesn't end in 9. 6 squared, 36, doesn't end in 9. 7 squared, 49, so 49 ends in 9, and 7 is one of our options. 8 squared, 64, no. And 9 squared, 81, again, no. So we can say that our root, the root of 44, 89, ends either in 3 or 4. So next step is chopping off the last 2 digits and just focus on 44, or just the first 2 digits. So we need to find a number whose score is closest to 44, and it must be equal or smaller than 44. So let's just go for, I don't know, 5 squared is 25. 25, okay. 6 squared is 36. 7 squared is 49. So 49 is bigger than 44. So this can't be our answer. So we need to stick with 6 squared. So 6 is our tens digit, right? That's the first number, the tens digit. So 6. The final answer is either 6, 3 or 6, 7. But which one? The last step is to multiply 6 that we found in the previous step by 6 plus 1, or 7. So 6 times 7 is 42, right? And now we need to compare 42 with the first 2 digits, with 44. So 44 is bigger. 44, our original number, is bigger than 42. So we need to choose the bigger number, 67, not 63. So 67 squared is 4489. So I think that's enough, because we covered 3 examples, and I think that's enough. So basically with this method, you'll be able to crack any perfect square 4-digit numbers. 5-digit perfect squares are pretty much the same. There is a little kind of difference. If you like that, I can just dedicate another video for 5-digit perfect squares. Now I have a challenge for you. Now I have a task for you. So as your task, find the... So this is a perfect square, and I want you to find the root of 7396. So 7396, you will start with 6. So you need to find which 1-digit number, single-digit numbers, has a square that ends with 6, and then go with step 2 and 3. So that's going to wrap it up for today, guys. I hope you enjoyed this video, and make sure to drop your thoughts and answers in the comments below, and like the videos, and subscribe to the channel if you haven't already, and see you on our next video on Prime Logic.